Hi everyone, in this video we are going to learn about parametric equation. So this is the last topic before we end the course in this semester. For you who had pre-calculus and trigonometry, this will be the end of the course. And for calculus and analytical geometry 2 students, this video will be the first part before our second part. The second part is actually the last part for the end of our course. Okay, so we're going to learn about parametric equation. What is actually parametric equation and what makes it different from the another equation that we know? So the collection of points defined by xy, so we still have a point xy, but x is defined by a function with t as variable, and y is defined by g with t as variable. This is called plane curve, and the equation x equal ft and y equal gt are called parametric equations. So parametric equation will consist of two things. Will consist of x equals something and y equals something, and x will be equal with an equal expression consists of containing t as the variable. But here in parametric equation we don't call it variable, we call it parameter. Okay, so the example are going to be learned after this. So what makes it different? We know that we usually have rectangular equation. In rectangular equation, we have y equal, for example, 2x plus 5. So we have here x is the variable. This is called rectangular because we are considering it in a rectangular Cartesian diagram. So this is x and this is y. So the relation between x and y, that's why we call it rectangular equation. But in parametric equation, we have a couple or a pair of equation. So we have x, for example, 2t, with t is a variable, a parameter, and y equals something with t. Let's say it's t square, for example. So we still draw it in x and y Cartesian diagram, but we have our parameter here. It's a parameter here to be analyzed. So the t is something that we're going to analyze in drawing the graph. There will be some interval for t if we want to draw the graph of parametric equation. Okay, so that what makes it different. Let's take a look at example. So for example, we have graph the curve given by this parametric equation. See that we have a pair of equation. We have x equal t square minus 4, and let me change color, and we have y equal t over 2. So this is our parametric equation, and this is the interval of parameter. So the parameter is actually t. So it's quite the same with drawing a graph of a rectangular equation. We only need to plug in the value for value of t to x and y. So let me use, so for example, here we have x equal t square minus 4. So here we have x equals t squared minus 4, if t, we know that our t will be from minus 2, negative 2 until 3. So here I set up the value here, negative 2 until 3. Actually you can, like, if you want to be sure, you want to put, for example, negative 1.5 and negative half, 1.5 is, it's actually up to you, but I just put the value t here. As long as it belongs to the interval, that will be okay. So if if t equal negative 2, we put it here, it will be 0, right? And if t equal minus 1, it will be 1 minus 4, which is negative t. And if 0, it's negative 4. If it is 1, will be 1 squared minus 4 will be negative 3. And 2 squared minus 4 will be 0 again. And we have 3 squared is 9 minus 4 is 5. So here we have our x value. Now for y value, it will be t over 2, so we divide t by 2. It will be minus 1 minus half, 0 will be 0, it will be half, and 1, and 3 over 2. Okay, so our point here will be 0 point minus 1 minus 3 minus half minus 4 over 0 and 5 3 over 2. Okay, so same thing, we will draw it. So let's make a line. Here we have, let's make it like this. Okay, so we have its x, its y, and put the point. So the first point is 0 point minus 1, 0. Or let's change, wait, say I put it like half thingy. So it's 1 2 3, 1 2 4 5 4 5. This one, this is minus 1 minus 2. Okay, 0 minus 1 will be here, negative 3. Oh, we don't have negative 3 over there, so let me change. Let me change the line. I don't know, let's just make the line. Here, negative 3. Negative 3 and negative half will be here. I have another one. Okay, it's okay. Negative 4, 34 0 will be here. Negative 3 half here. 0 1 and 5 3 over 2 is just 1 half. Will be here. Okay, so our graph is actually right. Okay, so this is the graph. So as you can see in this parametric equation, you see that the curve here is actually not a function. Curve is not a function, because if you put vertical line this like this, you will have like one value of x will have two value of y, which is actually not like violating the definition of function. So this is the the important feature of parametric equation. You actually can make a curve of a graph that is not function. So parametric equation has broader use like compared to function, because it can represent a curve that is not a function. So now what if we want to convert a parametric equation to a rectangular equation? It means we want to convert this to something like y equal blah blah blah, but this is the variable will be x, not t anymore. Okay, so it's pretty easy. We know that the equation x equal 3t squared and y equal 2t minus 2t only. Okay, so what we actually can do is just plugging in y to the x or x to the y. That's actually up to you. Let's try plugging in this expression to the x. So here we can change, like we know that t will be y over 2, right? So we can plug this t over there. Okay, so we will have, look at x equal 3t squared, and 3, the t is y over 2 squared. So we have 3 times y squared over 4. We have 3 over 4 y squared. So here is our rectangular equation. But remember that we have our interval of parameter. By this we can define our interval or domain of the rectangular equation. We know that domain means like the interval of x, right? We know that negative which we know x will be equal to 3t squared. So if t will be from -2 to 2, if we square it, we'll have 4, and this is like will be 4, which actually just like 0 from the t will be from 0 to 4, right? And if we times the t with 3, we'll have 3t squared 12, still 0, which this is actually x, right? So we have x, our domain will be 0 to 12. So the graph of this equation, let me change color here. So this, okay, is only defined in this interval of x. Here you go. Our second example will be a bit different. We have the equation, we have x equal 3 cos t and y equal 2 sin t. So t is from 0 to 2 pi. Okay, so how do we convert this to rectangular equation? We will make use of these identities. We know that cos square t plus sinus square t will equal 1, right? So we can make use of it and find the rectangular equation. So from the first, for x equal 3 cos t, we will need cos square t, right? So we have to manipulate this, and we will have cos t equal x over 3. Because we need cos squared, so we just squared it. So x will be x over 3, square will be x squared over 3. Oh, sorry, over 9. Okay, and y is 2 sine t, which sine t will be y over 2. So sine square t will be y over 2 square, y square over 4. So by making use of this, we'll re-plug in, so cos square t plus sinus square t equal 1. We have cos square t is x square over 9 plus y square over 4 equal 1. But again, we have to consider the domain. We know that x is 3 cos t, while the t is, our t will be from 0 to 2 pi. So considering that, we will have, for t equals 0, we have x will be 3 cos 0, which is just 3. And you know that the maximum value of cos t, so max value for cos t will be 1, right? Will be 1. So we will have 3, oh sorry, we will have x will be 3 times the maximum value is 1, which is 3. And the minimum value for cos t will be minus 1. So we have x equal 3 times minus 1. This is the maximum, this is the minimum, negative 3. So our domain will be from negative 3 to 3. So here you go. Okay, we have our equation, and we also have our interval.